Colorado television. Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment.
In this experiment, one can study the inelastic collisions that can take place between this cart and one of these shot-filled sacks as it drops into the cart. There's several of them that one can use with different masses. The experiment is performed by getting the cart moving with this spring, which is attached to one of the ribs of the track about 3/5 of the way down, of hooking it on underneath here, and then as the cart is accelerated, the spring will drop off. And since it'll drop off at the same point very nearly every time the cart moves, this work done on the cart is the same. That is the integral of FDS, and therefore the initial velocity when the spring drops off. One can measure that velocity using a photocell which interrupts a cylinder on the cart, and measuring the time on this clock counter might demonstrate roughly what happens and then indicate some of the precautions one has to take to get clean results. The cart can be held back here with a magnet. A little piece of tape is over the magnet so that the metal, the iron on the end there, doesn't stick to it. One can actuate the magnet with this button, the left-hand button here, and the right-hand button actuates this relay so that when one releases that button, the weight drops. First of all, one can simply accelerate the cart empty and measure its velocity, resetting the clock counter to 0, and stopping this at the end of the track and then reading the time. Or one can accelerate the cart initially with a mass in there. The same work is done on it, and one can remeasure the velocity. And finally, one can measure what happens when one starts the cart empty, but then drops this little weight in there as it goes by. That may take a little practice to do it, but we can try it once more. Let's try it again. And that time we measured it and So now, what does one have to do in order to get the experiment working as well as it can? First of all, with the track, one should level it crossways so that the cart doesn't bear to one side or another. And then one can get rid of some of the friction by tilting the track ever so slightly. One doesn't want it so that the cart accelerates, but if it push it and it comes to a stop only after a foot or two, then the friction will be negligible. Notice if I push it in the other direction, it comes to a stop much more easily. So that indicates. But if it goes clear to the end, and then it's probably tipped a little too much, and it would be accelerating slightly while it was rolling. Second of all, one wants to be sure that this device is far enough along the track so that the spring is dropped off the track before, and the cart has gotten to its final velocity before one drops the little sack on it. One can vary the height of this and see what the effect of dropping the sack from either from various heights is in addition. Finally, one wants to be sure that the photocell is working properly and is actually the light is being interrupted at the proper time. First, it's well to put one's finger through there and make sure it stops promptly. Sometimes the turning off the light will start it, but it won't stop properly. If that's true, one has to readjust the height of the light itself, or the photocell. If we look at what happens if this comes along here, you can see the shadow of the wheel and of the card itself and of the cylinder. It's the cylinder which will do the interrupting, and one wants to be sure that that is actually falling on this little bead right at the center of the photocell. That's the only sensitive part of the photocell. Notice the wheel doesn't interrupt the light, but now there's the cylinder, and as it goes by, it stops again. So with the light set at the proper height, one can have reliable measurements. One will have to measure the diameter of this cylinder. One will, of course, have to measure the mass of the cart and the mass of each of the little sacks that fall on here. I believe that's those are the main things that one has to do in getting the experiment to run properly, and one can try a fairly large variety of conditions in looking at these inelastic collisions. That's all.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television. This is University of Colorado.